Did you know that before any propeller is installed in a ship, it must go through a series of weird tests? No matter the size of any ship, its propellers are its most important components because they pivot the ship to move on water. But before a propeller is actually installed in a ship, it must have gone through a series of tests. Fish testing. Naturally, fish swim with tides and high waves. Some have studied that it is because they need to feed, or sometimes the wave is too strong and it just carries them along into anything it hits. For example, in any area known to be populated with fishes, cruise ships that sail in the area, and most likely other parts of the ocean, will need to have propellers that can get them through any fish attack. In test labs, before the ships are actually built, a model is first built with all necessary materials, and unlike old cruise ships, modern cruisers come with advanced technology. The test lab houses water that represents where the ship would sail and also the characteristics of life in the water. Although it doesn't happen frequently, fishes are often slammed against ships during storms and terrifying waves, and those that contact the propellers are swiftly disembodied. Smaller boats do not come with these types of large fans, so incidents with fishes in the open sea are rare. This simply explains the shape of cruise ship propellers, 3 or 4 large propellers that can tear anything apart. A ship's propellers help push the ship through the water. The propellers are often called screws because they slice through water and provide reverse or forward motion. Unlike the propeller of an airplane, a ship's propeller does not require tremendous effort to push the craft's speed forward, as it begins slowly with 250 to 800 revolutions per minute and advances from there. Corrosion and decay test. Unlike airplane propellers, modern ship propellers are made of either stainless steel or bronze alloy. Stainless steel is used because it is highly durable and makes repair relatively easy. Propellers made with stainless steel make ships have long careers and work through harsher conditions. On the downside, it's more expensive to maintain than the bronze alloy propeller because the stainless steel needs regular polishing to get rid of marine fouling, including algae and barnacles and others that tend to drag the ship down. Bronze, on the other hand, has natural anti-corrosive and anti-fouling properties. This makes maintenance minimal and it does not quickly absorb marine dirt. On the flip side, it is a softer material which can be easily bent out of shape or damaged if the propeller hits a stronger force. If this occurs, repairing may take a long while, which now leaves many modern cruise ships to using stainless steel propellers. Modern shipbuilding, including cruise ships, must account for how and where the ship is expected to be used, and choose the most cost-effective material for that situation. For example, the famous Queen Mary II used steel propellers because she was used as a modern ocean liner to cross the very rough North Atlantic. Allure of the Seas, another cruise ship used to sail much calmer tropical waters, uses bronze propellers. Azipods and bow thrusters test. The size of a ship mostly determines the type of ship propellers and how many propellers can be used to power the ship. A lot of cruise ships run on different propellers than regular cargo ships, and this is because cruise ships are much larger and tend to contain more apartments. Modern cruise ships nowadays use propellers that are attached to azipods, and these azipods are usually at the back of the ship. They can rotate to easily allow the ship to move in any desired direction. In much older ships, there were no azipods, so cruising in any direction resorted it to using rudders. Each azipod contains the motors driving the propellers. While propellers are naturally placed at the back of ships, some are usually kept in front. The propellers in front are known as bow thrusters, which are located in the bow to allow the front of the ship to be moved in any direction, whether to the right or left. Each azipod can rotate 360 degrees to let thrust be applied in any direction. Each azipod is independently controlled to allow control of forward speed while still allowing control of the rear of the ship. Ancient ships without bow thrusters and azipods could not rotate within their own lengths, and they used tugboats to achieve this. But propellers on modern ships have ceased the use of tugboats to help ships rotate within their own lengths. Bow thrusters are not as powerful as the azipods, and their functions are so limited that they cannot be controlled independently without proper connection to the azipods. A balanced operation of bow thrusters with azipods will allow the ship to move sideways, and when they are operated in opposite directions, the ship is able to turn in place. Open water test. Another weird propeller test is the open water propeller test, which calls for a lot of technical knowledge. The open water propeller test gives room for the propeller to not be obstructed by the hull and is fully exposed to the water around it. Open water tests are used to obtain several coefficients of a propeller, including the amount of power the propeller needs to function and the conditions in which it can function optimally. The thrust created by a propeller and the required torque are such coefficients that are measured with the open water test, and the name is derived because the propeller operates in a uniform flow. During resistance tests, the open propeller test ensures that wave patterns and wave resistance are similar to the full-scale vessel. During the self-propulsion tests, the propeller thrust, torque, and rate of rotation is measured. This test uses a model ship tested at speed that matches the same Froude number as a full-scale ship. In numerous cases, stock propellers are used, and they are selected in view of similarities in diameter, pitch, and blade area to the full-scale propeller. Self-propulsion tests often determine power requirements to run a propeller at capacity. Furthermore, the self-propulsion tests help supply ship wake field in propeller plane, and thrust reduction for the propeller design. When all of these coefficients have been measured and are found corresponding with the size of capacity of the ship, it is safe to assume the tested propeller is in proper working condition.